We have all these billions and billions of stars in our galaxy. The Milky Way alone has about 100 billion stars. And if even a tiny fraction of those stars have planets around them, and if even a tiny fraction of those planets have life, and if even a tiny fraction of that life is intelligent, well then the mathematics says there should be intelligent civilizations all over the place. Thousands of them, maybe hundreds of thousands. And the universe is about 13 billion years old, right? So some of these civilizations should be way older than us. They should have had time to build spaceships, to travel around the galaxy, and they should have visited us by now. But here's the thing, and this is the part that really gets interesting. We have no evidence of that. Not a shred. No alien visitors, no spaceships, no radio signals, nothing. Just silence. Complete cosmic silence. And this contradiction, this gap between what the math says should be out there and what we actually observe, this is what people call the Fermi paradox. It's a real puzzle. Now, most people, when they hear this, they think, well, maybe aliens are just very far away. Maybe space is too big. Maybe interstellar travel is too hard. And sure, those are all reasonable ideas, but they're not really the answer. Let me tell you why. See, I love to calculate things. I think it's one of the most fun parts of physics, just working through the numbers and seeing what they tell you. So let's do a little calculation here, just a rough one. The galaxy is about 100,000 light years across. Now, imagine an alien civilization that's only slightly more advanced than us. Maybe they can build spaceships that travel at 1% of the speed of light. That sounds really fast, right? 1%. Well, at that speed, it would take them 1,000,000 years to cross the entire galaxy. But here's the key point. The galaxy is 13 billion years old. That's 13,000 million years. So even if a civilization needed 1,000,000 years to cross it, they could do it over 1,000 times. They could colonize the whole galaxy and then colonize it again and again, over and over. And it doesn't even have to be one big wave of expansion. You can imagine this spreading like a wave, you know? A civilization on one star system sends out probes or spaceships or colonists to nearby stars. Those colonies then do the same thing. And it spreads and spreads like a ripple in a pond, even with incredibly slow speeds and long lifespans needed. You're talking about timescales that would fill up the entire galaxy hundreds of thousands of times over. So the question becomes even more puzzling. If this is even remotely possible, and it seems like it should be, then where are they? Where are all these civilizations? Now, this is where it gets really interesting, and this is where I think Fermi was getting at something deep. There must be something wrong with one of our assumptions. We're missing something important, and I want to talk about what that something might be. There's this idea that was developed more carefully by an economist named Robin Hanson back in the 1990s, and it's called the Great Filter. And I think this is really where the answer lies. Here's the idea. Imagine you want to build a galactic empire. You start with a simple planet, just a rock floating in space. And to get from that simple planet to a galactic empire, you have to pass through a whole series of steps. Necessary steps. You need certain conditions to form and certain developments to happen, all in sequence. Let me list them out for you. You need a star system with the right properties. You need a planet in the habitable zone, not too hot, not too cold. You need the right chemistry to happen on that planet. You need life itself to begin. You need life to develop reproduction using molecules like RNA and DNA. You need simple, single-celled organisms to evolve. You need multicellular organisms to evolve. You need sexual reproduction to happen. You need intelligence to develop. And this is a big one. Real, complex intelligence. Animal-level thinking. And then, finally, you need that intelligent species to develop technological civilization. You need them to figure out electricity, chemistry, physics, engineering. All of it. That's a lot of steps. A lot of things that have to happen. Now, the Great Filter idea says this. At least one of these steps is extremely hard, extremely unlikely, like nearly impossible. And that's why we don't see aliens visiting us. That's why the galaxy is silent. The question is, and this is the million-dollar question, where is that filter? Where is this extremely difficult step? Well, you see, this is where it gets serious. There are two possibilities, and one of them is genuinely depressing. The first possibility is that the Great Filter is behind us. It's something that already happened. It's something that's so unlikely that it almost never happens. But we got lucky and it happened here on Earth. If that's the case, then we might be one of the only intelligent civilizations in the galaxy, maybe even in our observable universe, and we could potentially spread throughout the stars and colonize everything. That's actually kind of nice, right? It means we're special. It means we have a future. But the second possibility, the one that's not so nice, is that the great filter is ahead of us. It's something that every intelligent technological civilization runs into, something that prevents them from spreading throughout the galaxy, something that destroys them or limits them. And if that's the case, then we're going to run into it too. It's coming for us. And when we do, it probably won't be very pleasant. So what could this great filter be? What could be so hard that it stops almost every civilization? Well, there are a few ideas. Let me go through some of them. One idea is that life itself is just incredibly rare. Life starting, the jump from non-living chemistry to actually living, reproducing organisms. Maybe that's almost impossible. Maybe it happened here by accident, by some incredible stroke of luck, but it almost never happens anywhere else. The universe might be almost entirely dead, with just tiny pockets of life here and there, separated by impossible distances. If that's the case, then intelligent life would be so rare that civilizations might never even encounter each other. They're just too far apart, and the universe is too big. They'd be like ships passing in the night, forever alone, unable to find each other. Another idea is that the jump to multicellular life is the filter. See, single-celled organisms are probably not that hard to create. They're simple, but multicellular life, organisms made of many cells working together, this is a much bigger jump. It requires coordination, specialization, all sorts of new biological systems. If this jump is very rare, then even if life exists all over the place, it's mostly just bacteria. Bacteria can't build spaceships. They can't develop technology. So the galaxy would be full of simple life, but no civilizations. Then there's the idea that intelligence itself is the great filter. See, intelligence is weird. It's not like other traits. For most of evolutionary history on Earth, there were no intelligent animals. And then, out of nowhere, in the last few million years, these primates. Us, we developed this crazy ability to think, to reason, to plan for the future, to ask questions about the universe. It's unusual, and maybe it's so unusual that it almost never happens. You'd have to get incredibly lucky to get an intelligent species. And if intelligence is the filter, then you'd expect the universe to be full of simple life, but intelligent civilizations would be vanishingly rare. But you know what? There's another possibility that I think might be even more likely, and it's darker. What if the great filter is not something that happens before you develop technology? What if it happens after? What if every intelligent species that develops technology, every single one, destroys itself before it can spread to the stars? Think about it. You're an intelligent species. You figure out physics. You figure out chemistry. You figure out how to split the atom. You figure out how to create nuclear weapons. You create nuclear weapons because you're still tribal, right? You still have tribalism in your DNA from when you were hunter-gatherers fighting over land and resources. So you get nuclear weapons, and now you can destroy your whole civilization in an afternoon. An afternoon, you can end your entire species. And that's just one way to destroy yourself. There are others. Climate change, engineered pandemics, artificial intelligence that you can't control, genetic engineering that goes wrong. There are so many ways to destroy yourself when you have advanced technology. And you create all these weapons and dangerous technologies long before you have the wisdom to use them responsibly. So here's the hypothesis. Every intelligent species eventually develops technology. And when they do, it's like a race between wisdom and destruction. Can they develop enough wisdom, enough maturity as a species to use their technology responsibly? Or do they destroy themselves first? And maybe, just maybe, the answer is that almost every species loses this race. Almost every intelligent species that gets technology destroys itself within a few hundred years. Maybe within 1,000 years. Some species might last longer, but not many. And that's why the galaxy is silent. That's why nobody's visited US. They're all dead. Every single one of them. They all figured out how to build spaceships and then figured out how to destroy themselves with those spaceships, or with something else, before they could use those spaceships to go anywhere. Now, I can't prove this, right? I don't have data from other civilizations. I only have one data point, which is us. But it does seem to match what we observe, doesn't it? It explains why we're not seeing alien visitors. It explains why the radio signals aren't coming. It explains why the universe seems so empty. And you know what's interesting? We're right in the middle of this race right now, this very moment. Humanity has figured out how to do some incredible things. We've split the atom. We've created nuclear weapons. We've genetically modified organisms. We've built computers that are starting to show signs of intelligence themselves. We have all these tools, all this technology, and we're still tribal. We're still divided into nations that point weapons at each other. We're still fighting wars over resources and land. We're still treating the planet like it's infinite, burning fossil fuels like there's no tomorrow, creating pollution, changing the climate. We're still creating technologies without fully understanding the consequences. It's like we're a child who just found his father's gun. We understand just enough to be dangerous, but not enough to be safe. And that's the race we're in. Can we grow up fast enough? Can we develop the wisdom and the social structures and the long-term thinking that we need to use these technologies responsibly? Or are we going to destroy ourselves? I think this is actually the most likely answer to Fermi's paradox. Not that space is too big, not that life is too rare, but that the great filter is self-destruction. That's why aliens will never visit. Not because they can't reach us, but because by the time a civilization gets advanced enough to build spaceships, it's already destroyed itself, or it's so rare that the other side of the galaxy, where they live, they destroyed themselves, and they're never coming this way. And this changes how we should think about our future. It's not just a theoretical physics problem anymore. It becomes a question about us, about whether we can make it, about whether we can survive our own intelligence. You know, when Fermi asked, "Where is everybody?" he was asking it as a physics problem. But I think the real answer to that question, the one that matters most, is about life and death, about civilizations rising up, developing technology, and then facing the test. Can they survive long enough to spread to the stars? And the silence of the universe suggests that most of them can't. But here's the thing, and I want to end on this note. We don't have to fail. We don't have to be part of that pattern. We have the knowledge to see where this leads. We can actually think about it. We can plan for it. We can work to prevent it. We have the luxury of knowledge. Most species probably don't. They develop technology and then they destroy themselves before they even understand why. They don't have the time to think about it. But we do. We can see the dangers. We can see what happened with nuclear weapons. We can see what's happening with artificial intelligence. We can see the climate change. We can see it all. And we know what it means. So we have a choice. We can continue down the path that every other civilization probably takes, the path to destruction. Or we can try something different. We can try to actually survive. We can try to be wise. We can try to take care of the planet. We can try to develop our technology responsibly. We can try to grow up as a species. That's why the question, will aliens ever visit, is really a question about us. It's a question about whether we'll still be here in 1,000 years or 1,000,000 years. It's a question about whether we can pass the great filter. It's a question about our future. And that's the real answer. Aliens won't visit because they never made it. They were all destroyed by their own technologies, their own tribalism, their own inability to mature as a species. And the question now is, will we be different? I don't know the answer to that. But I think it's the most important question we can ask ourselves. Not, where are they? But, will we still be here when the future looks back at us? And that's really something to think about.